Solve the system 5x plus 6y equals 3 and 10x plus 12y is equal to 6. Notice that both of the equations are in standard form and that none of the coefficients is 1. Therefore, the elimination method will probably be the most efficient method for solving this system. The idea is that we want to add the equations together and have one of the variables be eliminated. Right now that won't happen. 5x plus 10x is 15x. 6y plus 12y is equal to 18y. So what we need to do is to multiply one or both of these equations by some number so that when we do add the equations together, one of the variables will be eliminated. So what I notice is that if I were to multiply 5x by negative 2, that would produce negative 10x, and negative 10x plus 10x would be 0. So let's label the first equation as equation 1 and the second equation as equation number 2. And what we're going to do is to multiply the first equation by negative 2. So find negative 2 multiplied by the first equation. And for the second equation, we're just going to leave it alone. So that one will just indicate that we're going to just rewrite equation number 2. Now when we say we're multiplying an equation by some number, what that means is that we're multiplying each term in the equation by that number. So we need to multiply 5x by negative 2, and that gives us minus 10x. We need to multiply 6y by negative 2, and that gives us minus 12y. And we also need to multiply 3 by negative 2, and that gives us negative 6. We simply rewrite down the second equation, 10x plus 12y is equal to 6. At this point, we go ahead and add the two equations together. When we add minus 10x plus 10x, we get 0x. When we add negative 12y plus 12y, we get 0y. And when we add negative 6 plus 6, we get 0. Well, 0x plus 0y is simply 0, so we get 0 equals 0. Both of our variables are eliminated, and the end result is a true statement. So what does this true statement mean? Well, what it means is that every solution of one equation is also a solution of the second equation. In essence, when we graph the two equations will result in the same line. You might notice that equation number 2 is just a multiple of equation 1. If we were to multiply the first equation, every single term by 2, then we would end up with the second equation. So the two equations are really equivalent to each other. So every solution of one equation is also a solution of the second equation. So what this tells us is that there are infinitely many solutions. And the way that we write the solution set is we say it's the set of the ordered pairs x, y such that those ordered pairs satisfy one of the two equations. And the first equation appears to be a little bit simpler than the second one. So we'll write down the equation of the second line, which is 5x plus 6y is equal to 3. So A is our correct answer. Now if we'd like to support our answer graphically, what we might do would be to sketch a graph of equation 1 and a graph of equation 2. I'm going to go ahead and use the calculator as a tool to do that. And so what we'll need to do is to solve each equation for y. So let's write down the first equation. 5x plus 6y is equal to 3. In order to graph an equation on your calculator, you need to isolate and get y by itself. So let's take away 5x from both sides. 6y is equal to 3 minus 5x. Finally, divide both sides by 6. So y is equal to, and I'm just going to write it all on one line because that's the way that it needs to be entered into the calculator. We want to take the quantity 3 minus 5x and divide by 6. So this is going to be y1 on our calculator. In order to get y2, we'll take 10x plus 12y is equal to 6. Subtract 10x from both sides. 12y is equal to 6 minus 10x. And then divide both sides by 12. Y is equal to the quantity 6 minus 10x divided by 12. So now on our calculator, the first thing we'll do is to go to y equals, and we'll enter the first equation, the quantity 3 minus 5x divided by 6. Make sure that you use parentheses to enclose the 3 minus 5x. And once you've finished entering y1, then press enter to go to y2 and enter the quantity 6 minus 10x divided by 12. Again, make sure that you put parentheses around 6 minus 10x. Now because we have two different equations, it would be nice to sketch those graphs using different styles. So use your left arrow key to move to the left of y2. And once your cursor is to the left of y2, press enter so that it changes the style of the graph from just regular to thick. That way we'll be able to differentiate between the two equations. Alright, so now that we've entered the two equations into our calculator, we want a good viewing window. I'm going to suggest that we go to Zoom and select Zoom Decimal. Either Zoom Decimal or Zoom Standard. Both of those are good viewing windows. I'm going to select Zoom Decimal. So go to Zoom and select Zoom Decimal, which is number 4. It sketches the first line, and notice that as the second line is sketched, it goes right over top of the first line. What that does is it indicates that both of these equations represent exactly the same line. Therefore, every solution of one equation will be a solution of the second one. And to reinforce that, you might press trace. If you press trace, first of all, you see that the point 0.5 is on each graph. And then you can use your right arrow key to move from point to point. And all these different points that it shows us are solutions to the system. So another solution to the system is 0.60. but every single point on the line is a solution to the system, because every point on one line is also a point on the other line. So just in summary, the way that we write the solution is we write it as the set of ordered pairs x, y such that 5x plus 6y is equal to 3.